Hello, in this video we are going to learn functions used in octave programming. Now you need to know that mathematics have many functions. We have sine of a variable, we have cosine of a variable, we have tangent, we have cos h, we have the hyperbolic cos, we have the hyperbolic sine, we have the arc inverse of the sine and the cos with the tangent. We have all these type of functions, a logarithm, exponential functions, and with even index forms. So firstly, we are going to start with index form. An index form is just simple. If you want to write, let's say, we already know that the value of x that we have already coded in the initial tutorial is 30. So if you write x, you want to raise it to the power. So when you want to write x raised to the power, let's say you want x raised to the power of 2. If I write x raised to the power 2, you already know that the value of x is 30 here. So it's going to give you 900. So this is only how to write in index form. Now we have now the different variables which are involved now in octave. We have different functions which are involved in octave programming. The functions are going to be seen here. The different functions are cosine. When you want to write the answers, the variable, write it in bracket as such. So when you have cosine, you have sine, you have tangent, you have exponential, and all this. When you want to apply each, write the variable in bracket as such. So you need to know you have cos. Now when you want to place the cos, the values that you are going to place here are going to be in radian. So we know that a variable which is going to be conserved. Before we go into the function cos, we are going to know that octave programming considers a variable known as pi, and this pi is written as pi. So when you enter the value, you see that the value is exactly the value of pi, 3.1416. So I'm going to now do the cos with respect to the radian, because cos are going to the angles you are placing in the cos are going to be in radian and not in degree. So what you do, let's say you have the cos of pi. The cos of pi is going to be ans is -1. You see that ans is actually true. We have again the sine of pi. So the sine of pi is this. This is actually very small, so it can be approximated as being 0. So when you see this e is just times 10 raised to the power -16. So when you see this e here. Now you have cos, you have sine of this. You can also use the tangent of this. So the tangent is Tn of pi. So this is very small. So you can have here is 0. So now this is how to use the different main functions in octave programming. The other functions which are used in octave programming are cos. We have the cosine of angle. The angle are used in radian. We have sine. With the sine of angle is used in radian. You have tangent of angle is used in radian. You have exponential, logarithm. This log here is the ln, it's to the base e and not to the base of 10. So an example, we can take it in octave program. When you write just log, let's say I write log of e. Before we enter log of e, you need to know the value of e, and e is actually e in mathematics. So we write e, the value is given as such. So when I enter log of e, I'm going to have argument must be numeric. So you have to enter a value which must be numeric here. So what happens is that I'm going to place this value 2.7183. So I'm going to say log of 2.718 So when you want to write the log to the base e, you write here log and write in bracket e. You know the value of e remains the same as mathematics. You have answer equals to 1 here. So now the other function you can have is log to the base 10. You come here, you have log to the base 10 here. Log to the base 10, you are going to use, let's say 1000. So you have 1000 here, and you have this. The answer is 3. So you have the different, you can have arc sine. So you have this, you have arc sine, you have you can have arc cos, you can have arc tan, you can have the different one. You have the sine h, which is given as such. We have the cos h, which is given as such. We have the tan h, which is given as such. Now you need to know that I have created a function initially and I have integrated with my editor, and I can now calculate the sine. I can now, initially you see that this sine here that we have to calculate, this function are using in radians. So if I come in my code and then I write just sine of 90, we normally know that sine of 90 is equals to 1, but the answer is not going to be shown to us as 1. It's going to be given as this. So if you also write sine of 30, we normally know that this is half. So but the answer is not going to be a half to us. It's going to be this. I have created a function, and I'm going to tell you how to create functions with particular codes. So I've created a function called sine d. So this sine d, I can now use the degree and paste inside. Let's say I paste 90. You see that the answer is 1. This function, I've created it and I've placed a certain format that that I've integrated with my octave program. So now when I write sine d, I have 90 of 90. The answer gives me 1. And this is actually the sine of degrees. So I can have sine d again of 30. So you see that it's going to be 0.5, and this is actually the answer that we are going to have with a sine of 30 as being a degree. So we are going to see this in the next tutorial. So lastly, if you want to round numbers, you have the absolute values here. So we have 2 argument inverse tangent. We have absolute values. You have sine. If you want sine of number, if you want the sine of the number, you use this. You have round the number to the nearest integer. We have floor, we have C, we have fixed, and all that with their different properties. And if you want to know much more property, come to documentation and visualize the functions you want. So from here we say thanks for your kind attention, and don't forget to like and subscribe for the channel Science Video Makers. Thank you.